Hey class, because I don't want to post my test answers as a PDF, I'm just going to have a recording of me scrolling down, stopping on each question for like a second or two. You can pause, check your answers with that if you want to. Otherwise, just prepare for a test and good luck. Make sure you use your calculator to your advantage. This is the limit stuff. We did this the last couple of days. Just remember, there's like the three type of problems we could have. When you graph this, if they're going in the same direction, they're the positive infinity. If it's going down, it's a negative infinity. And if it's going opposite directions, it'll be neither or undefined. Or it does not exist, technically, would be the correct term. By throwing in an identity there. All right, let me explain this a little bit. This one right here, because this is a fourth power and second power, I do factoring just with cosines. And because I have a cosine squared minus 1, I can turn that to sine squared. This one on the left, they're a difference of squares. And because secant squared minus tan squared is -1, and I can rewrite secant squared as 1 plus tan squared, which becomes 1 plus 2 tan squared. This one, I make it a common denominator, so it's 1 minus cosine squared over cosine. 1 minus cosine squared is sine squared. Then I split it, so then I could have sine and cosine to be sine tan. This one, you have to solve for it. Again, kind of the same concept as the previous question, make it a common denominator. I do a little extra. I make the sine. All I could have done is just added sine to both sides, the 1 over sine to both sides, then multiply everything by sine. Would have done it faster. Either way, you get in a situation where you get sine x equals plus or minus √2 over 2, and that's all the 45-degree angles. This one, much easier than the previous one. Again, all the 45-degree angles. This one over here, I did the sum, so 30 plus 45. I feel like that's much easier. You could do a half angle equation, which is sine of 1/2 of 150. You could do technically that. I feel like it was a little bit tougher, so I recommend just doing the angle sum rule. These should be infinite solutions. I usually say all reals. That's not correct, actually. It should be infinite solutions. This one, I have to get rid of the denominator on the bottom. So I multiply everything by 15. This one, I just substituted. So anything in the blue underline, I substituted that. And then solve the quadratics. Since I get two x's, I'm going to get two pairs of answers. So I'm going to get two pairs of answers there. Same concept here. It's a quadratic. Going to get two x's. That means I need to get two y's. This one, there's multiple ways to do it. I do it the row reduction way. It is sometimes the longest route, but it will always get you there. If you could see, I think Mitch mentioned something very smart. You could use this row 3 to help you eliminate a lot of things. Particularly, you could use row 2 and row 1 to cancel out both the x pretty quickly. And then you could use this and this to replace the x and y. Either way, there's multiple ways. You can use matrix and other things. This is just a circle. Remember, your testing point doesn't have to be 0, 0. I chose -2, 4, but it could be anywhere where it's obvious. So like you could have picked here and it's obviously not on the line. That's very important when you have a quadratic like this. That I know it's going to be on the left, but that's just because of experience. You might have confused that. I remember that happened on the test, so make sure you test something unique. This, you have to make sure you do complete the squares, simplify everything, make it equal 1 at the end over here. The asymptote, remember, it's the y value over the x value and the square root, so 3/4. That gives you the slope. I guess I should explain this a little bit. Since we know the vertex, this is your h and k, so your h and k pops up here. Since we're going up and down, that means the x value is getting manipulated, kind of like a normal parabola. You have the left side of the x and the right side of the x, so that's why it's x squared, and y is a single variable one. And then 4p equals 4 because the distance between here and there is 4. Same concept here. It's going to be in between the major vertices, so I could get my x's and y's. And then the distance gets me my a and b. Number 6, 6a, 9c. So because it's like this, you could use this equation over here, which is the same as the Pythagorean theorem, to get square root of 45 equals b. But it doesn't matter because it's square root 45, because in the equation, it gets squared back to normal. So that's why it's okay that it's the square root in that situation, because in the equations will be squared back to normal. And then you have to identify that the center is 0, 0. So 0, 0, you just put x squared and y squared. All right, that's it, guys. Use this to your advantage. If you have any questions, you can always email me. Have a wonderful day.